Let me introduce myself. My name is M.Adhe Akbar with NPM 223121103. Let me explain about the branch and bound is powerful technique for solving optimization problems, particularly those involving combinational decision. It works by symmetrically exploring all possible solutions, but it cleverly uses bounding function to burn out branches that cannot possibly contain the optimal solution. This makes it much more efficient than simply trying every single possibility. Here how it works. The first one is divide and conquer. The problem is first broken down into smaller sub-problems. This often done by making choices at each step, such as whether to include a particular item, a knapsack or not. Bounding functions for each sub-problem. Bounding function is calculated. This function estimates the possible value, minimum cost, and maximum profit that could be achieved by any solution within the subproblem. Pruning if the bound of subproblem is worse than the current best solution found so far, then it's no need to explore the subproblem any further. It can be safely pruned from the search tree. The second one is exploration. The algorithm continues to explore the most promising subproblems based on their bounds. This typically involves choosing the subproblem with the tightest bound. One that is closest to current best solution. Eventually, the algorithm will explore all of the remaining subproblems and find the optimal solution. And here's an analogy to help illustrate the concept. The first one is imagine you are the lost in a maze and trying to find the exit. Branch and bound will be like trying to all the different paths, but with a special ability for each path, you can estimate how close it is to exit without actually going all the way down it. If a path is definitely further than the best path of you already found, you can skip it and you try different one. This saves a lot of time and effort compared to simply trying every single path. Branch and bound is a powerful and versatile technique that can be applied to a wider range of problems. Some common. The one examples include the knapsack problem is deciding which item to pack in knapsack with limited capacity to maximize the total value. Traveling salesman problem is finding the shortest possible route that visit a set of cities once and returns of the sorting point. Job scheduling problem is assigning jobs to machines in a factory to minimize the total completion time. But bin packing problem is packing item into bins of limited capacity to minimize the number of bin used. And branch and bound is not always the fastest way to solve a problem, especially for large problems. However, it can be very effective technique for finding the optimal solution for even for complex problem with many possible solutions. And the deeper into this deep into specific different types of bounding function, it is there are various ways to calculate bounds depending on the problem. We can explore examples of linear programming, Lagrangian relations, and other bounding technique. The second one is algorithmic implementation. It is different strategies exist for exploring the search tree, like deep first search or bound first search. We can discuss the pros and cons approach. The third one is complexity analysis, understanding the time and space complexity of branch and bound. Algorithms can help assess their suitability for particular problems. Application beyond combinatorial. While classic application like indiscrete implementation, branch and bound can also adapt to continuous optimizing problems with certain constraints. Additional aspects to consider. And then the fourth one is parallelism. Exploiting the potential for parallel computing can significantly speed up branch and bound algorithm. And the fifth is hybrid approach combining branch and bound with other optimization technique like matrix can sometimes lead to even better result. And challenge and limitation, it is no algorithm is perfect, and branch and bound also faces certain limitation in specific problem scenarios. Okay. And then the conclusion is finding the optimal solution. This is the ultimate goal to reason we embark on the entire exploration of the search tree. When the algorithm eventually stops having as many L promising branches and prioritize it present the goal middle solution, they want to minimize the cost, maximize the profit, or fulfill the objective function in the best possible way. Understanding the solution space, the journey through doesn't just deliver the final answer. It also reveals valuable insight about the entire landscape possible solution. The bounds calculated at each node shed light of the range of potential outcomes, providing information about the near optimal solution and identifying areas where improvement are unlikely. Thank you. Maybe that's for all. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.